Hello and welcome to another Bytes on a Budget video. Today, I'm testing NVMe SSD speeds on PCIe Gen 3 versus PCIe Gen 4. I got curious about this after installing a Gen 4 NVMe drive into a Gen 3 M.2 slot and wondering how much performance I'd actually lose. The motherboard here is an MSIB 450 MA Pro Max with a Ryzen 5 3600. This CPU provides 24 PCIe Gen 3 lanes, 16 for the GPU, 4 for the M.2 slot, and 4 for the chipset. The B450 chipset itself only supports PCIe Gen 2, but the M.2 slot is wired directly to the CPU, so it still runs at Gen 3 speeds. PCIe Gen 3 offers about 1 GB per second per lane, and since the M.2 slot uses 4 lanes, the theoretical limit here is around 4 GB per second. For the SSD, I'm using a 500 GB Intenso NVMe drive rated for up to 5.3 GB per second read and 4 GB per second write, faster than what Gen 3 can fully take advantage of. Shortly after doing a clean Windows 11 install, I ran Crystal DiskMark to test the disk transfer speeds, and here are the results. The most important numbers are from the sequential test with multiple queues. Sequential means the benchmark reads and writes data in physically adjacent sectors on the disk, similar to copying large files. Multiple queues means the benchmark sends several input/output requests to the drive at the same time. The final test result shows about 3.3 gigabytes per second for both reads and writes, which suggests the drive is being limited by the PCIe Gen 3 interface. The SSD itself is capable of higher speeds, so I'm curious to see how it performs in a PCIe Gen 4 M.2 slot. I'm going to test the same NVMe drive in my Gigabyte B650 Gaming X motherboard. This board uses the AMD B650 chipset, supports Ryzen 7000 and 8000 series CPUs, and provides 36 usable PCIe Gen 4 lanes. Out of those, 8 PCIe lanes come directly from the CPU and are dedicated to NVMe storage, which means the board can fully support high-speed Gen 4 drives. The motherboard has 3 M.2 slots. 2 of them are wired directly to the CPU, offering the lowest latency and highest performance. The third slot connects through the chipset, and that path adds latency and shares bandwidth, because it uses an extra 4 PCIe lanes for communication back to the CPU. For this test, I want the best-case scenario, so I need to use one of the CPU-connected slots, either M.2A or M.2B. My primary SSD already occupies the M.2A slot, so I'll install the test drive in the M.2B slot. The M.2C slot runs through the chipset, so it wouldn't give us the fastest results, and isn't ideal for a direct Gen 4 comparison. Now that the disk is installed, I'm ready to start the test. I'm choosing the correct drive in Crystal DiskMark, which, in my case, is drive D. Then, I'm selecting the first sequential test. And a while, the results are there. The results are much better than before. 5.3 gigabytes per second for read versus 3.3 gigabytes per second, and 4.8 gigabytes per second for write instead of 3.3. A theoretical maximum transfer rate for 4 PCIe Gen 4 lanes is 8 gigabytes per second, so it seems that this time we are actually hitting the limit of the disk drive, rather than the PCIe lanes. So, to conclude, when choosing NVMe SSD drives, it's important to pair the drive with the correct CPU and motherboard chipset, so they both support the same PCIe generation. But also to use the correct M.2 socket, because on some motherboards, some M.2 sockets are connected to the CPU, while others connect through chipset, which increases latency. Also, some motherboards might support lower PCIe generation on the M.2 socket connected through the chipset, for example, Gen 3, while the CPU is actually capable of higher speeds provided by the PCIe Gen 4. That's it for this video. If you like it, hit the like button and subscribe to the channel. Until next time.